Good morning, students of grade 10. We are going to continue to our lesson. Last time we studied about acceleration due to gravity, and we also proved theoretically that acceleration due to gravity is independent of mass. Okay, do you remember that or not? We proved that g is proportional to 1 by r square, and the relation shows that g is not not dependent on mass. Okay, that we did last time. Please, if you have forgotten, go to our last class. Okay, now today let us discuss about feather and coin experiment. And the feather and coin experiment, it aims to demonstrate that the same thing, acceleration due to gravity is independent of mass. Acceleration due to gravity is independent of mass. Okay, to demonstrate acceleration due to gravity is independent of mass. Okay, the aim of feather and coin experiment is to demonstrate acceleration due to gravity is independent of mass experimentally. Yes. Now this experiment was performed first by Robert Boyle. Okay, Robert Boyle performed the feather and coin experiment first. It was later replicated by Sir Isaac Newton as well. And this experiment is based on earlier demonstration by Sir Galileo Galilei. You have heard the name, yes? Galileo Galilei. Earlier demonstration by Sir Galileo Galilei that acceleration due to gravity is independent of mass. What Galileo did, he went to the Leaning Tower of Pisa. Okay, he went to Leaning Tower of Pisa, and from the top he threw two objects of having different weight from the top. He threw two objects having different weight. In normal circumstance, what happens? The heavier object falls, reaches the ground first, and lighter object later. But in this case, he showed that both objects reached the ground almost at the same time. Okay, by this experiment with Pisa's tower, Galileo Galilei showed that acceleration due to gravity or is not dependent on mass. But the scientific community back then was not convinced with the experiment, and later on Robert Boyle and Sir Isaac Newton independently performed an experiment to verify the point. Okay, now in feather coin experiment, what they did was, first of all, they took a glass tube. Okay, they took a glass tube, and in glass tube they kept a feather which is very light and a coin, and being made up of metal, coin is very heavy. They kept a feather and coin in the glass tube, and then he simply inverted it. By inverting inverting the tube, what they observed as usual is coin reached first, a coin fell faster, and feather, it fell slowly. Feather flutters and falls slowly. Okay, this is usual observation. Yes, and in next step, what they did is they used a vacuum pump. Okay, this tube is connected to a vacuum pump. Okay, once again the same feather and coin, but this time all the air has been drawn out. The vacuum is created inside the tube. Okay, so there is no air inside the tube, and after it is made vacuum and again it is inverted, then what is observed that both coin and feather is falling at the same time. See, in first experiment, what they did, they simply put feather and coin in a glass tube, and then they inverted it and observed that coin falls much faster than feather. And in second step, what they did, they used a vacuum pump to create vacuum inside the glass tube, and after creating vacuum inside it, again they inverted the tube. This time what they observed, coin and feather both fall together. Okay, now both of them fall with same speed or same acceleration. In this case, acceleration of feather was much slower than coin, but in this case both have same acceleration. Now if acceleration due to gravity depends on mass, would it be possible? No, definitely not. This won't be possible if acceleration due to gravity is dependent on mass. But both of them are falling together means acceleration due to gravity is independent of mass. It shows it that acceleration due to gravity is independent of mass. Now, what reason can you provide that in presence of air, coin falls faster than feather? Is it that in presence of air, coin experience more gravity? No, actually no. The reason is air provides upward force. Yes, air provides resistance. And what do you call it? We call it upthrust. Okay? Air provides upward force, which is called upthrust. And upthrust is directly proportional to surface area. It is not dependent on mass or weight. Upthrust is directly proportional to surface area. And you know, feather has more surface area than coin. So feather experiences more upthrust, and due to that upthrust, feather falls slowly than the coin. Okay, that is the reason. Are you getting it or not? See feather coin experiment. Now how you need to make a report on the experiment. Give title first. And what is your title? To conduct, okay, to verify that acceleration. Wait a minute, let me adjust it a little bit. Okay, now it is clear. Yes, acceleration due to gravity is, pen is independent of mass. Okay, this is our title. Okay, and what are the objective? Okay, objective is okay. Let me do like this. Okay. Objective and title is feather and coin experiment. Okay, let me correct it. Title is feather and coin experiment, and objective is to verify that acceleration due to gravity is independent of mass. Now, what are the materials required? Materials required are, it is you need a glass tube, and then vacuum pump, and then feather and coin. Okay, this much you're going to need. Now what is the procedure? Okay, first of all, what we did, a feather and coin were placed in a glass tube containing air. Then the tube was inverted and observed. Okay, a feather and coin were placed in a glass tube containing air. Then the tube was inverted and observed. And in second step, what you did, vacuum was created in the tube with the help of a vacuum pump. Then the tube was again inverted and observed. Okay, in first step, what you did, a feather and coin were placed in a glass tube containing air. Then the tube was inverted and observed. And in second step, vacuum was created in the tube with the help of vacuum pump. Then the tube was again inverted and observed. Then let's give the observation here. What do we observe? Okay, first of all, when there was air in the tube, coin falls faster than feather. Okay, and the second observation was that when there was no air in the tube, no air means vacuum, yes, when there was no air in the tube, coin and feather fell together. Okay, fell together. So this was the observation. And what was the inference here? Inference is, how do you explain this observation? In presence of air, air provides upthrust that cancels out some amount of weight or amount of gravity. Okay, why is it so? In presence of air, air provides upthrust that cancels out some amount of gravity. It is because gravity acts in downward direction, upthrust acts in upward direction, and both are force, and force being vector quantity, they cancel out each other. Okay, feather has more surface area and then coin, and experiences more upthrust. So feather falls slowly. However, in absence of air, both feather and coin fall under the influence of gravity alone and fall together. See, the observation can be explained in this way. In presence of air, air provides upthrust that cancels out some amount of gravity. A feather has more surface area than coin and experiences more upthrust, so feather falls slowly. However, in absence of air, both feather and coin fall under the influence of gravity alone and fall together. Okay, now you can the conclusion here. The conclusion is acceleration due to gravity is independent of mass. Okay, I hope you have taken the note. See, If you're asked to experimentally prove that acceleration due to gravity is independent of mass. If you need to prove experimentally that acceleration due to gravity is independent of mass, then this is what you have to do. You can use the same figure. Yes, you can use the same figure. Give the title feather and coin experiment. The objective to verify that acceleration due to gravity is independent of mass. Materials required: glass tube, vacuum pump, feather and coin. Procedure: a feather and coin were placed in glass tube containing air, then the tube was inverted and observed. Vacuum was created in the tube with the help of vacuum pump, then the tube is again inverted and observed. And what is our observation? When there was air in the tube, coin fell faster than feather, and when there was no air in the tube, coin and feather fall together. An inference: how do you explain the observation? In presence of air, air provides upthrust that cancels out some amount of gravity. Feather has more surface area than coin and experiences more upthrust, so feather falls slowly. However, in absence of air, both feather and coin fall under the influence of gravity alone and fall together. Now, a conclusion: acceleration due to gravity is independent of mass. Okay, this much concludes the feather and coin experiment. Okay, now let's go to next topic we have. It is free fall and weightlessness. Okay, while we were discussing about feather coin experiment, while we were discussing about feather coin experiment, here we came upon a situation where both feather and coin are falling under the influence of gravity alone. Okay, so whenever an object falls, whenever an object is falling toward earth, there are two kinds of forces are acting upon it. Okay, whenever an object is falling on falling object, okay, whenever an object is falling toward earth or toward any planet, two kinds of forces are acting on it. Okay, let me focus on earth first. One of the force is gravity. Yes, and gravity acts in downward direction. Okay, and gravity, amount of gravity is also called weight. Okay, weight or gravity acts in downward direction. And another force is upthrust. Upthrust by air. Okay, see, so gravity is acting downward direction and upthrust is acting in upward direction. Okay, on an object, on any falling object. So being both of them force, gravity is also amount of force and upthrust is also amount of force. Yes, and you know force is vector quantity, and vector quantity can cancel out each other if they are acting in opposite direction. So upthrust cancels out gravity. Okay, let us suppose that we have two objects, object A and object B. Okay, weight of both object is 50 Newton. Both of them have 50 Newton weight. Yes, if there is no interference, then both of them would fall at the same speed or same acceleration. But let's say object A has more surface area and object B is compact, then more upthrust will act on object A because of its large surface. But on B, because of its small surface, upthrust would be less. Now let's say 20 Newton of upthrust is acting on A, whereas on B only 5 Newton of upthrust is acting. Yes. Now what is the net force by which object A is falling down? That would be 50 minus 20, 30 Newton. Okay, 50 minus 20, 30 Newton. The object A is falling down with the force of 30 Newton. Whereas in case of object B, In downward direction 50 Newton force is being applied. In upward direction 5 Newton force. That means it is falling with 45 Newton of force. See, can you see that? Yes. So obviously in this case what happens? Object B falls faster, whereas object A falls slower. Okay, any confusion up here? I hope not. Now let's consider another example. Once again, the same objects, both objects having same amount of weight, but there is no air. Okay, there is no air. That means there is no upthrust. Means both of them would be falling with same amount of gravity. So both of them will fall at the same time. Okay, fall together. See, so this second condition, second case where objects are falling under the influence of gravity alone. Okay, here objects are falling under the influence of two kinds of force, gravity and upthrust. Yes, in first case objects are falling under two kinds of force, gravity and upthrust, whereas in second case objects are falling under the influence of gravity alone. Okay, now this kind of fall is called free fall. Okay, this is not a free fall, this is just a fall, normal fall. Okay, the normal fall in which object falls under the influence of two kinds of force, gravity and upthrust. Okay, in normal fall objects fall under the influence of gravity and upthrust, but in free fall objects fall under the influence of gravity alone. Okay, so let me define upthrust now. I need to get another paper. Okay, free fall is defined as the situation in which an object falls under the influence of gravity alone. Okay, or you can also say in absence of any resistance. Okay, now some examples of free fall is object falling toward moon, falling on moon. See, moon does not have any atmosphere, so any object fall only with gravity, under the influence of gravity alone. Now let's consider the case of a parachute. Okay, this is Earth's surface. A man is on the parachute. Yes, the man is on the parachute. Let's say weight of the man is 650 Newton. It is acting downward direction, and since parachute has very large surface area, air provides much more upthrust, and which creates the resistance. And let's say air provides around 500 Newton of upthrust, then the overall force by which man is falling down would be only 150 Newton. The person would be falling toward the earth with the force of just mere 150 Newton, or you can say the acceleration is cancelled by upthrust. The man falls slowly, and as a result the man can safely land on earth. Okay, see, there is two kind of force acting on him, upthrust and gravity. Okay, now let's consider the same situation on moon. Okay? On moon, definitely the weight of man itself is very low. That is to say, let's say 650 divided by 6. 6 1 6 6 0, 56, 9, 6, that's 8, so 48. Okay, 108. The man is okay, on moon his weight would be only 108 Newton, and since there was no air, there is no upthrust. Okay, no upthrust, and this is just gravity, and on moon he would fall with the same force. Yes, there is no upthrust. Okay, there is no upthrust means the man is falling under the influence of gravity alone. Okay, got it or not? So in case of moon, if you jump with parachute or without parachute, it does not matter. If you jump without parachute, then also you would be experiencing same amount of force. Okay, there is no upthrust. So this is the case of free fall. There is no upthrust or there is no air resistance. The object, whether you are with parachute or without parachute, you fall under the influence of gravity alone. But on earth, if you jump without parachute, you might be near free fall, but with parachute it is not a free fall. That is why on earth you might safely land with a parachute, but on moon it is that is not so. On moon, whether you jump with parachute or not, it is the same. There is no difference. Okay, so the question is frequently asked, what is the difference in jumping with parachute on the moon or the earth? Okay, you take this question, try to solve it. What is the difference between jumping with parachute on the moon and the earth? Okay, your answer should be that on the earth there is air, there is atmosphere which provides upthrust, okay, which cancels some amount of gravity, and the person does not undergo free fall. But on the moon, since there is no air or atmosphere, there is no upthrust. Okay, as a result, the person falls under the influence of gravity alone. Whether he has parachute on or not, it does not make any difference. The person falls freely on moon. That should be okay. That is the difference between jumping with parachute on moon and the earth. Okay, now let's go to next topic. The next topic being weightlessness. See, the word says everything that it needs to say. Weight, amount of gravity, isn't it? And weightless means absence, and ness means the condition, showing condition, the condition, like laziness, happiness, sadness. Okay, the word ness, ness indicates the condition. Okay, weight, amount of gravity, less absence, ness, the condition. So it says weightlessness means the condition where there is absence of gravity. Okay? It itself says the condition where the absence of gravity means weight appears to, in absence of gravity, weight appears to 0. Yes, or becomes 0 is called weightlessness. Okay, the condition where the weight appears to or becomes 0 is called weightlessness. Now, in what condition weight of an object becomes 0 or they appears to be 0? Let's discuss the conditions here. Suppose you are falling in space. You are in space. Then in which direction will you fall? In which direction? basically there is no direction in space. Okay, because there is no gravity, means you will keep on floating. You will keep on floating. There is no definite direction of your movement. Okay, and in this case, since there is no gravity, there is no weight. Okay, no gravity means no weight. We define weight as the amount of gravity acting on an object. Okay, amount of gravity acting on an object is known as weight. Now, if there is no gravity, then there is no weight. See, in space you can feel weightlessness. In space you can feel weightlessness. Okay, now take an example of Earth. On Earth, suppose an object is this is an object. How do you measure its weight? Definitely some amount of gravity is acting on it. Let's suppose the let us avoid the effects of upthrust here. Okay, uh, some amount of gravity is acting on the object and that measures its weight. But how do you measure weight of an object? We use a spring balance, isn't it? We use a spring balance to measure its weight. Okay, now the spring provides some resistance to gravity. Okay, the spring provides some resistance to gravity due to the tensile strength of the materials of string. Okay, spring. Okay, the spring is made something like this, which have very high tensile strength, and which means which tend to recoil to its original position. If you stretch it, then it tends to go back to its original position, and that strength provides the necessary resistance to gravity. Okay, and when the resistance become equal to gravity, then the object stops falling, isn't it? Suppose this is a spring balance. In original position the object is kept here. Suppose at original position it exerts less force. There is no retraction. Okay, the object, then there is some amount of gravity. Yes, and when it falls by this much amount, then there is some amount of tensile strength. There is some amount of retraction. Yes, also known as elasticity. Okay, and because of that elasticity being less than weight, the object keeps on falling downward. Suppose the object the spring reaches up to here, and it increases its elasticity or its tensile strength. It wants to recoil. Okay, and that stress being equal to, when that stress become equal to weight of object, it stops at that point. Yes, so how much tensile strength is here, that indicates the weight of object. This is how we measure weight in by using spring balance. Okay, see, the resistance is needed to measure weight. Okay. However, what we said in free fall, object falls under the influence of gravity alone. Yes, in free fall object falls under the influence of gravity alone. That means no resistance. Now see, if there is no resistance, then how can we measure weight? If there is no resistance, then how can we measure weight? Weight cannot be measured. Yes, I'm not saying there is no weight, but I'm only saying that we cannot measure weight of an object in absence of resistance. Okay, to measure weight, measurement of weight depends on resistance. Actually, we are not measuring weight, but we are measuring resistance. Okay, while taking weight by using spring balance, we are measuring resistance, which is needed to balance the weight. Okay, and we take a reading of resistance, that becomes equivalent to weight. But if there is no resistance, if we are not allowed to provide any resistance, then we cannot measure weight. So under free fall, it is impossible to measure weight. So the weight appears to be 0. What I'm saying? Weight is not actually 0. In this case, the object has weight. Okay, please focus here. The object under free fall, it has weight. Okay, since gravity is acting, some amount of gravity is acting on it, it has weight. It has some weight. But because there is no resistance, we cannot measure weight, and weight appears to be 0. Okay, appears, only appears. It is not actually 0, it appears to be 0. So this condition is also referred as weightlessness. Understood or not? I discussed two cases here. In first case, we are in space where there is no gravity. That means no weight.